Hey pre-calculus students, this is our first extra practice video. These will be posted on our website in this same tab. These will just be places for if you have an intervention class, this is what you'll be working on in there if you're in pre-calculus, or if you need extra practice on a certain concept for review or whatever. So for our objective for today, students will be able to find the midpoint between two complex numbers, and then we'll have a way we interpret that as the average. And we'll also be able to find the distance between two complex numbers. And this went along with lesson 11 in our core class. So if you hadn't done lesson 11's work yet, probably should go work on that first, see where we came up with these formulas. This is just extra practice using our formulas. And then our standard, this is basically all we need to know for this standard is how to find the midpoint and distance between complex numbers. I forgot a couple S's. Okay. So in our class, in lesson 11, and in our video, we discovered that the midpoint is, we wrote it as a plus b over 2, or the sum of two complex numbers. I'm going to write it just another way today, just so we can see another way to look at it. For two complex numbers, we'll say they're z1 and z2, because often we see complex numbers written as z. Then their midpoint will just be z1 plus z2 all over 2. So for any two complex numbers, whether we call them a or b or z1 or z2 or whatever else, their midpoints just we add them up and divide by 2. For the distance, in the lesson we saw it was the modulus of a minus b. Again, I'm just going to write it a different way with z1 and z2. It's going to be the modulus of z1 minus z2. So these two formulas are what we need to find distance and midpoint. They work out, they give us the same math that we'd be doing with our normal distance formula. Our normal distance formula of like x1 minus x, or x2 minus x1 squared plus y2 minus y1 squared. That's our standard distance formula for coordinates. But because complex numbers already have the real and imaginary parts separate, we can just do these with subtraction and modulus instead of a whole formula like that. Okay, so those are our formulas. Again, if you didn't get this, I would go back to lesson 11 first and watch that video, and then come back to this one. But for today, let's find the distance and midpoint between two numbers. I'm just going to give them names. I'm going to call this one Z1 and Z2 because they don't have names here. And then plot the points and their midpoint. All right, so we're going to find the distance and midpoint, and then we're going to plot points. So I'm going to make a little list for myself so we don't forget anything. So find midpoint, that's something we need to do. Find the distance, and then plot. Okay, let's find the midpoint first. So our formula, z1 plus z2 over 2, midpoint equals z1 plus z2 all over 2. I'm going to use some colors so we can see these a little better. Z1 is going to be red, Z2 is going to stay blue, Z1 is red, Z2 is going to be blue, all over 2. So we'll plug them in. And again, it's really important that when we plug expressions in, that we include our parentheses. Zoom in a little bit. Include our parentheses, because when we plug in these numbers, when I plug in Z1, I'm going to be plugging in negative numbers. And the same when I plug in Z2. And sometimes it's really easy to mix up our signs if we don't keep track by putting parentheses on them first. So I just opened up spaces where I was going to put Z1 and Z2, plug them in. Now we're just simplifying. At the end, we should get a complex number that's the midpoint. All right, simplifying. Real parts, negative 8 and 3. Imaginary parts, negative 3i and negative 4i. So the yellows are going to add up to negative 8 and 3. So we're down at negative 8. We're going to go up 3, negative 7, negative 6, negative 5, negative 5. And then negative 3 and negative 4, negative 3, take away 4 more, negative 4, negative 5, negative 6, negative 7. So negative 7i. And I think out loud through those subtractions just to give you another way to think about it. Whatever works for you for subtraction, go ahead and do that. And then lastly, we want to write this as a point. So I'm going to split these two up, negative 5 over 2 minus 7 over 2, oops, let's see, 2, 7 over 2i. So that's our m. That's the midpoint. All right. So let's quickly find our distance. Oh, notice if we don't like these fractions, we could also rewrite them as decimals. 5 over 2, that's more than 2, that's 2.5. Negative 2.5 minus 7 over 2 is 3.5i. So that's another way we could write it, especially if you prefer to plot with decimals. That's always good. All right. So now the distance. Distance is the modulus of z1 minus z2. It doesn't actually matter if we did z1 minus z2 or z2 minus z1. These are the same because we're going to be taking squares, so all the negatives won't really matter. But let's just stick with our z1 minus z2 for right now. So again, keep the modulus. I'm going to plug in my numbers. Z1 in red, Z2 in blue. Z1 is negative 8 minus 3i. Z2 is 3 minus 4. Wrote our formula, opened up spaces again with the parentheses. Oops, look what I did. I forgot a negative. It's a negative. Got to keep it as a negative over here. This is where these parentheses end up being really important. So, fix my formula, plugged in our numbers. Now, we're saying we're subtracting both of the parts of Z2. We're subtracting the real and the imaginary part. So I'm going to rewrite this below. I'm going to have to keep our negative distributed to both. So negative 3, negative positive 3 is just going to be minus 3. And then negative negative 4 is plus 4i. All right, I don't need these parentheses anymore. Just keep my modulus on there. All right, let's combine our like terms. 8 and negative 3, that's going to be negative 11. Negative 3 and positive 4, that's just positive 1i. Great. So now we have a complex number, and we have to take the modulus of it. So normally we take a modulus using a plus bi. That's saying modulus of this number here. It looks like our a is going to be negative 11. And our b is going to be, our b is just the coefficient on I. It's not I itself, it's just whatever's attached to I. Here we have 1i, so b is going to be 1. All right, so we have our a and b. And our formula for modulus, if we had modulus modulus of a plus bi, that would be the square root of a squared plus b squared. That was our formula for modulus. All right, so equals square root of a, which is negative 11 squared. Again, I use the parentheses to keep that thing I'm plugging in, plus b, which is 1 squared. 11 squared is 121 plus 1. So it looks like 122 to me. Square root. You're welcome to simplify this if you like. Sorry, write this as a decimal. I don't think it would simplify. I don't see any perfect squares in there just looking at it. It's going to simplify to just over 11 or 11.04. Okay. So distance, again, we write down our formula right here. We're like, plug in our numbers, plug them in. We didn't take the modulus until the last step because we want to just have one number inside a modulus. Once it's in there, it's pretty easy to take